some exponential equations. What you want to do first is change so that the left and the right side of the equal sign have the same base. So in this case, we have a base of 2. On the right side, we need to change our 256 to have a base of 2. So 256, let's see, we need to change that to have a base of 2. So 256 is equal to 2 to the 1, 2, 3, 4, 5, 6, 7, 8 power. So my left side stays the same, but my right side, I say 2 to the 8th power. And now that we have the same base, they both have 2, what I can do is I can set their exponents equal. So x equals 8. Then you can check that answer because 2 to the 8th power equals 256. And you can double check that. It's 256. So we know we got that right. Our x has to be 256. Or sorry, x has to be 8. For number 2, we have on the left side a base of 5, and on the right side we just have 625. So we need to change the 625 to have a base of 5. 625 divided by 5 is 125. So that means 625 is equal to 5 to the 4th power. And now that we have the same base, we have 5 and 5, what we can do now is set the exponents equal. We can set the 2x equal to the 4 and solve for x. 2 times 2 equals 4, so that means x has to be equal to 2. And then let's check it. 5 to the 2 times 2 power equals 5 to the 4th power. And if you were to multiply that out, you get 625. So we know we got the right value for x. Number 3, we have a base of 4, and then on the right, we just have a 64. So we're going to change our 64 to have a base of 4. So that'll be 4 to the 3rd power. 1, 2, 3 equals 64. But then we have a new issue, and that is that on the right-hand side, our base is in the denominator, so we need to actually move it to the numerator without actually changing its value. So we'll have 4 to the 3 minus x power, and then we're just going to move this 4 to the 3rd power up to the numerator, so we'll make our exponent negative. And you can see that, let me show you. If I did 1 over 4 to the 3rd power, that's equal to 0.01565. And then if I do 4 to the negative 3 power, notice how they have exactly the same value. So I didn't change the value of the number on the right-hand side. All I did was I changed the position. By making the exponent negative, I'm able to move that 4 to the 3rd power up to my numerator without changing the value of that number at all. So now that I have the same base, I can set these exponents equal to each other. Now I've got a 4 and a 4, and I can set those exponents equal. And I'll end up getting a value for my x. So negative x equals negative 6. If I divide by negative 1, I'll get x equals 6. And I can check that by substituting my 6 in right here. 4 to the negative 3 power, does that equal 1 over 4 to the third power? And it does. And we just checked that actually on the graphing calculator here. 4 to the negative 3 is equal to 1 over 4 to the third. So we know we did get that right. For this next one, I'm actually going to add a page because I'm kind of out of space. So 3 to the negative 4x equals 729. And I don't have the same base. On the left side, I have a 3, and on the right, I have 729. So let's make our 729 have a base of 3. 3 goes into 729, 243 times. And then 3 goes into 243, 81 times. 3 goes into 81, 27. 9, 3, 3. So we know 729 is the same thing as 3 to the 6th power. So now that I have the same base here, they both have a 3. That's good. Now I can set these exponents equal to each other. And I'm going to solve for x. So we'll divide both sides by negative 4. So x is negative 3 halves or negative 1.5. Either way would work. Let's substitute in that for our x right here. I'm going to take this value, and I'm just going to substitute it in for the x and verify that it really does equal 729. Negative 4 times negative 1.5. And it does equal 729, so I know I got the right value for x in that case.